Okay, so we're going to do one more example. We're going to find the volume of a solid whose base is bounded by the same functions. We have our parabola y equals 2x squared minus 2x, the line y equals x, and the line x equals 1. But this time the slices, when we slice perpendicular to the x-axis, they're going to be equilateral triangles. So when we think about an equilateral triangle, again, we're going to have the base of this equilateral triangle is going to be given by the distance between the line and the parabola. But you may not know the formula for the area of a triangle just in terms of its base. So let's look at an equilateral triangle. That's my best impression of an equilateral triangle. So this is our base, is what we have, and we need to come up with an expression for the area. Well, area of a triangle is 1/2 base times height. So we have to think of a way to write the height of this triangle in terms of the base. But since this is an equilateral triangle, all three sides and therefore all three angles are equal. So these are all 60-degree angles, which makes this half of an angle 30. So we have a 30, 60, 90 special right triangle. This side is 1/2 base because it's half of the base. And so this height here is going to be the base times radical 3. So our area is 1/2 base times square root of 3. And so we can combine our coefficients. So this is square root of 3 over 2 times base squared. So the area of an equilateral triangle in terms of the base only is radical 3 over 2 times base squared. So as usual, when we want to find the volume of the solid, by the way, I didn't show you the solid this time. Let's look at that solid again. What we're looking at is this is our base, but when we rotate it around, we see that each cross-section has a slice of an equilateral triangle. So that's our solid here. That's what that looks like. Okay, so I'm sorry, back to the computation. So if I want to find the volume, I'm going to integrate over the bounds from x equals 0 to x equals 1 of the area of my triangle. So that's going to be radical 3 over 2 times the base squared. Now, if you were looking at the previous examples, we've already computed this base. The base is going to be the distance between this line and this parabola. So it's going to be x minus the parabola 2x squared minus 2x. When we combine like terms, that's going to be 3x minus 2x squared. So here's our area expression. We're going to integrate from 0 to 1. Okay, so we can pull out our coefficient, radical 3 over 2, the integral from 0 to 1. And we have an expression that should look familiar to those of you who saw the previous two examples. We've already computed this integral right here to be 4/5. So this is square root of 3 over 2 times 4/5. So we get 2 radical 3 over 5. That's the volume. Oops, ran out of room. That's the volume of this solid right here. This solid right here. And again, for those of you that didn't see how to integrate, how to find this expression, we can use our graphing calculators. And we have, this is under Math 9, the function, comma, the variable, comma, the lower bound, comma, the upper bound. And we get that that's 4/5.